In order to obtain the action selectivity of transformer longitudinal differential protection, the setting value of its action current must be greater than the maximum unbalanced current in the differential circuit. Due to the different voltage level, winding wiring mode, current transformer type and transformation ratio on each side of the transformer, as well as the inrush current of the transformer, the unbalanced current in the longitudinal differential protection of the transformer is large. The greater the unbalanced current, the lower the sensitivity of the protection. Therefore, analyzing the causes of unbalanced current in transformer longitudinal differential protection and reducing its impact on protection are the problems to be solved in longitudinal differential protection. In the power system, large and medium-sized transformers usually adopt the wiring mode of Y and D11. Therefore, the phase difference of line currents on both sides is 30 degrees. Even if the values of TA secondary current are equal, due to different phases, a differential current will flow into the differential protection device. As the rated voltage and rated current on each side of the transformer are different, the models of current transformers installed on each side of the transformer will be different, and their saturation characteristics and excitation current will be different. Therefore, the unbalanced current generated in the differential circuit will be large. Because current transformers are finalized products, when selecting current transformers, the calculated transformation ratio of current transformers on each side cannot fully comply with the standard transformation ratio of current transformers produced by the manufacturer. Then IAMP will appear in the differential circuit. The transformer on load adjustment tap changes the transformation ratio of the transformer. If the transformer longitudinal differential protection has been adjusted according to a certain transformation ratio, when the tap is changed, a new unbalanced current will flow into the differential circuit. In order to reduce this unbalanced current and ensure that the protection will not misoperate in case of normal operation and external fault, microcomputer-based transformer longitudinal differential protection usually adopts software method to adjust the current on each side. The Y-triangle phase correction mode of microcomputer transformer differential protection means that the phase correction of current is carried out on the star side. The current phase of the star side of the transformer is adjusted by the protection software algorithm to make it consistent with the current phase corresponding to the triangle side. Triangle Y phase correction means that the phase correction of current is carried out on the triangle side. The current phase of the triangular side of the transformer is adjusted by the protection software algorithm to make the current phase corresponding to the star side consistent. For the unequal current on each side of the transformer, the microcomputer transformer differential protection adopts software to adjust the current. The balance coefficient is introduced to adjust the current balance on each side. Methods to prevent the influence of inrush current. When the power supply is restored after the no-load or external short circuit of the transformer is cut off, a large inrush current may be generated, which will lead to the misoperation of the longitudinal differential protection. IX according to the characteristics of magnetizing inrush current, the methods of transformer longitudinal differential protection to prevent the influence of magnetizing inrush current IX are generally as follows. Longitudinal differential protection with second harmonic braking. Inrush current discrimination element with measured wave width and discontinuity angle is used to block longitudinal differential protection. The principle of waveform symmetry is used to identify the inrush current, and the inrush current discrimination element blocks the longitudinal differential protection. At present, a large number of protection devices use the comprehensive inrush current criterion of phase breaking to distinguish the characteristics of fault current. Combining the respective characteristics of fault waveform, unilateral inrush and symmetrical inrush. The second harmonic, waveform identification, waveform discontinuity comprehensive criterion and algorithm are adopted to ensure that the device can accurately distinguish the magnetizing inrush current and fault waveform, and can act quickly in case of fault, and can be locked correctly in case of no-load closing.